Hello students, welcome to Saurav Sir's classes. Today we are going to solve a few questions on differential equations. The question is, consider a system of first order differential equations where d dt of xt yt is equal to xt plus yt and minus yt. The solution space is spanned by option A 0 and e to the power minus t and e to the power t and 0. Option B e to the power t is 0 and cos ht and e to the power minus t. Option C is e to the power minus t and minus 2e to the power minus t and sin ht e to the power minus t. And option D e to the power t 0 and e to the power t minus half e to the power minus t and e to the power minus t. So now the given differential equation is actually d dt xt yt is equal to the matrix 1 1 0 and minus 1 xt and yt. Thus the eigenvalues of the associated matrix are 1 and minus 1 and the corresponding eigenvectors are 1, 0 transpose and minus half, 1 transpose. So basically the eigenvectors are 1 and 0 and minus half and 1. Thus the solution of the system is given by xt yt is equal to c1 e to the power t 1 0 plus c2 e to the power minus t minus half and 1. So now for option A, the span of the given vectors is a e to the power minus t 0 1 plus b e to the power t 1 0. On comparison, we get a is equal to c2, b to the power t is equal to c1 e to the power t minus c2 by 2 e to the power minus t, or b minus c1 into e to the power t is equal to minus c2 by 2 e to the power minus t. The second condition is not possible for large t. Therefore, option A is incorrect. Now, for option B, the span of the vectors is a e to the power t 1 0 plus b by 2 e to the power t plus e to the power minus t 2 e to the power minus t, which is equal to a plus b by 2 e to the power t 1 0 plus b by 2 e to the power minus t 1 and 2. Comparing it with the solution, we get b is equal to c2 and a plus b by 2 minus c1 e to the power t is equal to minus c2 e to the power minus t. So again, this condition is not possible for large t. Thus option B is incorrect. Now for option C, The span of the vectors is given as a e to the power minus t minus 2e to the power minus t plus b sin ht e to the power minus t is equal to b by 2 e to the power t 10 plus e to the power minus t a plus b by 2 and minus 2a plus b. Now on comparing and using the fact that exponentials are never 0, we get a is equal to 2c1 minus c2 by 2 and b is equal to 2c1. Now since we are able to find the relation between AB and C1 C2, so this result holds. And for option D, for this case, we get A is equal to C1 minus C2 and B is equal to C2, and this also holds. Therefore, option C and D give us the correct answers.